So we're back in Onshape. Today we're going to design a bracket to mount this type of motor. This is a JG370Y motor. You'll be receiving all these dimensions for the motor, and later on as we move into our electrical and electronic and our mechatronics parts of this course, you'll also receive more information off the data sheet for this motor. We use these motors a lot. It's a really good example for what you're going to use in your project. So as you can see, all the dimensions are on here. I'm going to go through I'm going to go through making this bracket without actually referring back to these dimensions because it will make it too long-winded. The idea is that you have to work out what the dimensions are from the bracket, from the motor data sheet, and design your own bracket. The video I'm making is just to show you some ideas of how to go about that. So what we're going to do is we're going to start a new design. So we're going to start a new document. I'm going to call it JGY370 demonstration. Going to create. Now, while I'm doing this, you're going to have to bear with me because it's quite complicated and there's quite a lot of things in here. So if I stop and start again or have to go back or make mistakes, that's okay. You're going to make plenty of mistakes while you're making it, I'm sure. Okay, now, first thing we're going to do is we're going to import a model, a previously prepared model of the motor so we can make sure that everything fits. So we're going to add a new tab here. That could be a part studio or an assembly, but we're going to choose import. And then you're going to go to wherever you're storing the stuff. This design will be in the learning task. You'll just download it. This is the file. It's called Worm Drive Motor JGY370 exported SLDPRT. SLDPRT is a SolidWorks file. All right, so this is quite good. It imports all the appearance and everything from the SolidWorks file. SolidWorks is another CAD program you might possibly use if you do engineering at university. Okay, so now we can close this window. We can see a new window has appeared for CAD imports. That's because we've imported that from CAD. But here is the actual part studio. See, it's got the symbol for a part studio here with the actual motor in. So that's very useful because I just found this off the internet. I just searched for it and downloaded the 3D model for it. That's very handy because we can use this in our design to make sure everything fits. Okay, now we go back to our original part studio. Also note that I've got my laser joint and auto layout already installed here. Now I'm going to make a sketch. Like I say, the idea is for you to get the dimensions and design this yourself. I'm just giving you an idea of how to do it here. So I'm going to create a sketch. I'm going to put it on the top plane here. Start a rectangle. I'll make this dimension here. Might make it 90. Enter, and I'll make that one 60. Enter. Okay, dimensions are on there, so it's all black, so that's good. Go like that. Turn that off. Now I'm going to extrude that by 3 millimeters because the material we're going to be using is 3 millimeters thick. All right, and then just like when you went through, oh, I must have not accepted that. Let's accept that again. So 3 millimeters. And then obviously it's important you click that button before you do anything. Just like we're going to make this a finger jointed structure. All right, so if we're going to make it a finger jointed structure using the laser joint, you have to have done the laser joint tutorial first, otherwise you might get a bit confused. We have to make our parts overlap. So when I make my upright part that the motor is going to mount on, so we're going to make a right angle bracket now. I'm going to hit sketch, and I'm going to sketch on the bottom of this. Okay, here I'm going to grab my corner rectangle. You see how it's snapped to the extents of the original rectangle, the original sketch. Now I'm going to make that 3, enter, and then escape, and then escape out. Yes, escape out, because I don't want to give this line a dimension because it already knows it's snapped to here. So if I give it a dimension, it's going to get confused and be over constrained. So I've got 3 millimeters here though, but the lines are still blue. It's because they don't know how far from the edge they're meant to be. So I'm going to go in here and I'm going to dimension them from the edge by, let's say, 15 millimeters. Okay, so now I'll finish my sketch, and then I'll be able to extrude up by clicking on this part, extrude up. Now the thickness, I want it 40 millimeters high, but the thickness of the material is 3 millimeters, so I'm going to make that 43. Now that's not very helpful because it's all one part, you see? They're all the same color, it's all one part. We can't do our laser jointing if it's all one part, and we can't laser cut a shape like this either. So what we're going to do is we're going to go back into the extrude and we're going to make it new. So it's actually, in my extrusion I actually made a new part, and you can see there's 2 intersecting parts there. All right, now that's quite good. So let's bring our motor in. So the way we do that is we use the derived tool. Now derived just means it comes from somewhere else. So I'm going to hit the derived tool. It's going to say select the part studio. Whether if it's in this document or other documents, doesn't matter. You can still drag that part in from there. So I'm going to hit here. Okay, so now it's showing me where it's going to come, and I'm just going to put it in there, and we'll sort it out in a minute where it goes to. Okay, now we're going to move it exactly onto here. So but what I'm going to do first is I'm going to get it just in the right orientation. I always find it's easier just to do that. So I'm going to go to the transform tool, which is this one. Click on the transform tool, and I'm going to say rotate. I'm going to click on this part. See, now it's got part 1 here. That's part 1. And you've got to pick an axis. So the first thing I want to do is rotate it. If I pick, I'm going to pick an axis, this axis, and I'm going to rotate it around here by, well, it's going to be 90 degrees, isn't it? Okay, so now it's rotated like that, and now it's facing the wrong way. I want it to be mounted the other way on the bracket. So I'm going to do another transform. But I've lost the transform tool. Here we go. So I'm going to click on it again, and I'm going to rotate it again, but this time I'm going to choose this axis, and I'm going to rotate it by 180 degrees. Type it in. Okay, and now it's kind of in an annoying place now, so I'm going to rotate by X, Y, Z, and then I can drag it out here, and I'm going to go, okay. All right, so now it's out the way. Oh, I need to rotate it again. I want it to face the other way, so let's rotate it again. Transform by rotate, pick the axis. This time it's that axis. 180. Now you can see this is red here, doesn't know what to do, so we're going to pick out, I'll do that again. Transform this part by rotate by axis by that, and I'll make that 180. All right, so now eventually we're going to line this up with here, but the first thing I need to do is I need to decide where the motor's going to go and how I'm going to line it up. Now obviously if this shaft is going to stick through here, we're going to need a hole, so I'm going to put a hole in there. So I might, I'll do another sketch on here. So I'll do a new sketch and I'll put it on here. Go to the front because that's the way we're looking. And now I'm going to put a circle in there. I'm going to make that circle 8 millimeters in diameter. Okay, now it's blue because it doesn't really know where it is. Now the motor's going to sit here, so we need to do some calculations with the drawing here. So in terms of height, if it's 32 across there and I want a millimeter underneath the motor, then I'm going to need the hole to be off the base. I need it to be 16, 17, 18 millimeters off the base. Okay, so I'm going to put in a dimension between here and here, and I'm going to make that 18. And then I actually want it to be about 20 from the end. Okay, so I need to put another dimension in because it still doesn't really know where it is. So I'll put another dimension in from here. I'm going to make that 20. No, actually, I'm going to make it 25. You'll see why. Like I say, this is up to you to work out the dimensions from the drawing. Now, I finished my sketch. I'm going to push a hole in here. Make that 3 millimeters. What happened there? Put my sketch back on. That didn't seem to work, so let's do this. Ah, didn't hit the remove button, that's why. 3 millimeters. Right, now I've got a hole. Now I want this to stick out of here exactly how it is, okay? Now, how do we do that? Now, there is a very handy tool in the transform. So when we go to transform, click on this. We did translating by line just now, rotating, translate by XYZ, but we can transform by mate connectors. Now, mate connectors are very interesting. This is actually the symbol for a mate connector, this one here. You can do it through here, but we're going to do it with this. Now, this is the from, and this is the to mate connector. So what we have to do is we have to make like a mark telling it where we want these things to be transformed. Now this is where it gets a bit hairy because you've got to be very careful about exactly what you want mated. Now I want this face, so I go the from mate connector. I want this face, not this face, this face, or this face, but this face, the center of this face. And you see the little blue line saying it's pointing this way? I want that little blue line, the center of this face pointing that way, the center of it. That's the from mate connector. Now, I want it to, and I'm going to want it to this hole on this side, not on the other side, not that one, this one. So I'm hoping, but the little blue line's got to point the right way while I'm doing it as well, so sometimes it's hard to get it to do what you want. I don't want to pick the whole tube because it will put it in the middle of the tube then. How am I going to do this? I had this before. Sometimes it's quite hard to get it to decide on what you want. I want the blue line pointing this way so it's all lined up. But so what we can do, there's lots of different ways of doing this. So if I did it with the blue line, oh, almost had it then. If I did it with the blue line facing that way, and I select the entity to transform, it's on the wrong way, okay? It's the right place, but it's the wrong way round. So what we could probably do is we can leave it like that, and then I can rotate it again, or I can try and get it to match up with exactly the right place. So let's open it. So the great thing is you can always open the transforms and open all the operations again, And let's try and change the 2 mate connector to where we actually want it to be. Actually, no, let's just delete that. And we'll start again. So it'll go back to where it was now. Let's try it again. Transform. Transform by mate connectors. So we want to, let's try and pick the 2 one. Yeah, I don't know why it won't pick exactly what I want here. Okay, well let's do it to that face and then we can move it back a bit. So now it's going to on that face, and then we'll go the from mate connector we know is easy to find. That's this one. And I pick the entity. So now it's moved it here, but I need to move it, but it's stuck to the front of this piece of acrylic. I want to move it back. So I can just do another transform and do a transform by distance. Pick the direction. Pick the entity. No, actually let's do it with translate by XYZ. Okay. And now I can actually type in here which way I want it to go. So let's make sure we got this the right way. Yes, that's the way. So now it's moved back 3 millimeters. Okay, so now it's exactly stuck to there. The shaft's in the center of the hole that it's designed for, and it's on there. Now, we're also going to have to make holes through here to match up with this as well. So what's the best way of doing that? Well, let's see if we can do a sketch on here and see where that's. Okay, so I want to do a sketch on the back there, but I can't see the holes. If I turn off part 3, then I can't see where the holes are either. If I turn it around like this and turn off part 2, I can see that. So let's see if we can we'll get rid of where the sketch has got to be, and we'll make the sketch plane on the face of this one. Because now, if I look at the front, I should be able to draw. No, it's not picking up those parts, is it? Yeah, it's not matching up with those holes exactly. We have to make it so that it should. And now, here we go. No, it's not matching up with those holes, so we'll get rid of that. All right, so we have to make it so that it's gonna. We know exactly where those holes are on here. Now, I'm not quite sure how to do that, but let's have a play. Let's turn off this part. Let's do a new sketch. And hopefully we can sketch. It wants us to select a sketch plane. I actually just wanted to sketch on this part here, and it doesn't seem to want to let me do that. Let's turn the sketch off here. All right, so now we should be able to sketch on this plane. So we're sketching on the face of the derived one, which is the motor. So if I draw a center point circle now, it's going to let me do it. So although it's not letting me pick the center of these circles. Okay, so how are we going to manage that? It's only letting me pick the outside of them.